Hello friends, this is the solution video for question number 25, chapter 5, HC Verma. The problem statement says, consider the situation shown in figure. All the surfaces are frictionless and the string and the pulleys are light. Find the magnitude of the acceleration of the two blocks. So in this problem, first of all, we will resolve the component of the mg acting downward in both the cases, and we will write the equation of motion, and then using the free body diagram, we can solve this equation very easily. Fine. So if I make here like this is the mg force acting downward, there is a reaction force which is perpendicular to the contact surface. Say if this is theta 1 and say this is theta 2, so this is going to be mg cos of theta 1, and there is a force which is mg sine theta 1. So let's say this is the mass m1, so I'll write m1, m1 and m1 here. Okay, similarly this m2g acting downward, this is the theta 2 and there is a reaction force r here. So this is m2g cos of theta 2, and there will be another component which is m2g sine of theta 2. Okay, so the first challenge is going to be to calculate this theta 1 and theta 2. So to calculate this theta 1 and theta 2, we can use the cosine formula in the triangle, which says, suppose I have a triangle, say having side A, B and C. So this angle is going to be A, this angle is going to be C, and this angle is going to be B. So I can calculate angle cos A, which is equal to B square plus C square minus A square upon 2BC. So using this formula, in this triangle I have side, this is 3, this is 4 and this is 5. So the cos A, or I can say cos of theta 1, will become B square means 3 square plus C means 5 square minus 4 square upon 2 times 3 into 5. So if you solve this, this will become 3 upon 5. Now I have to calculate this sine theta 1. So sine theta 1 is under root 1 minus cos square theta 1. So this means 1 minus 3 square upon 5 square, or it will become 4 upon 5. Similarly, you can calculate this theta 2, that means cos of B, which is say cos of B, or cos of theta 2 will become A square plus C square minus B square upon 2AC. So using this, I'll get sine theta 2 is 3 by 5. Okay, so now I can say FBD, say this is block A and this is block B, and when we release this, say this is going in this direction with an acceleration of A. Okay, and there is a tension in the strings T and T here. Fine. So FBD of A is going to be something like this. So this is the block, this is T, this is m1g sine of theta 1. Fine, and the acceleration is in the same line A. Okay, so if it is accelerating in the right hand direction, so that means T is greater than m1g sine theta 1. So this will become T minus m1g sine theta 1 is equal to m1 times A. Value of m1 is 1 kg, so I am putting the values. T minus 1 into g, sine theta 1 value is 4 by 5, is equal to 1 into A. Okay, so if I solve this, so this will become t minus 4g by 5 is equal to a. So this is equation number 1. Similarly for fbd of b, so in that case, say this is the b block and there is a force m2g sine theta 2 acting downward direction, tension t here, and the box is moving with an acceleration a in this direction. So for this case, the equation will become m2g sine theta 2 minus t is equal to m2a. Again the m2 is 1, so this will become 1 into g into sine theta 2 value is 3 by 5, so this is 3 by 5 minus t is equal to 1 into a. So if I solve this, so this will become 3g upon 5 minus t is equal to a. Say this is equation number 2. Now adding equation 1 and 2, we will get 3g by 5 minus 4g by 5 is equal to 2a. Okay, so that means this will become minus g by 5 is equal to 2a. So the acceleration is minus g by 10. So that means this system will move in this direction, okay, because there is a minus sign. Okay, so I'll say acceleration is g by 10 moving left side. So this is the solution of this problem.